Hey yo, what's up? What's up, everyone? It's your boy. Oh, is that dry? Is that my lips getting dry? Okay, it's your boy JOSHABRAHAM. And we're back with physics. I got physics, just like the title is read. I got my physics exam in about 3 hours. God damn it. God damn it. We're past the exam. No. I actually planned on waking up at 5. I woke up at 6. Mm-mm-mm. Yo, my phone is still not working. Do you got 31st? We got 31st, okay. In hand. To do in hand, we have to do equations on paper, on screen, on hand, with hand. Ow. So, we're looking at this one. We got two types of route. 8, 3, root of a squared plus 3, 5, 4. No way, it just crashed OBS. OBS crash? What happened, OBS? What made you crash like that? Is it the iMovie? I'm guessing. Mm-hmm. Oh, come on. Shut the fuck up. So we got route A and we got route B. Determine the next acceleration of the body at the route A. So coefficient of friction 0.2 theta equals opposite by no sine theta is equal to opposite by hypotenuse. Cos theta sine theta. Come on, come on, come on, come on, come on, come on. Net force. Let's calculate the net acceleration along route A. S1. Okay, that's distance. Okay, force in y direction. We're going that route. Force in y direction. We got G. We got perpendicular. What is G1? G1, I believe that's friction. I'm guessing that's 2 theta, right? That should be theta. I forgot the law, but yep, that is theta. Now that's FR. FN GB. On an inclined plane with angle theta, the net force along the plane F net equals mg sine theta minus friction. F friction equals coefficient times mass g cos theta y. So first in bidirection, that acceleration equals nu Fn. I'm having a slight confusion on the mg sine theta. how the uh, when considered as x and y component, it goes to be cos v sine, but how is that working here? I found that tan alpha equals h by L. Opposite, okay. So from that, alpha is 20.56. Okay. That is not useful. Do we got tan inverse? Yep, we have tan inverse. Start from the force, gravity, weight of the object is a vector. mg direction vertically downwards. Choose axis adapt to the incline. Instead of horizontal vertical axis, we choose x-axis along the inclined plane perpendicular to the plane. Okay, okay. This makes motion focus easier to analyze. Decompose gravity into components. We compose the force in the same way. Geometry of the incline, the plane is tilted by the angle theta. The angle between gravity and normal direction is theta. Gravity and normal. I thought it was this one that we took. Okay, this. Okay, that's how it got to sine. Wait. So here. Theta from normal and the mg. So the vertical, the horizontal sine or cosine depends on the angle you're using. Theta is measured from horizontal. Though, okay, here's theta is measured from vertical. The component adjacent to the angle uses cosine. The component opposite to the angle. From normal direction, the vertical mg. Triangle. Okay, okay. And okay, okay. The angle, the component opposite is sine. Opposite sine. And this one would be cos. So f is equal to mg sine theta minus mu mg. How is now it's cos theta? Okay. Okay, now I get that. Then how is the f from friction but so the question becomes, what is the normal force where cosine becomes comes from? Now apply Newton's second law perpendicular to the plane. The body does not accelerate into or away from the plane, so the net force perpendicular to the plane is zero. Force perpendicular to the plane, normal force, component of gravity. Plug in friction formula. This is why friction has cosine. Friction is coefficient of friction times normal force. Normal is gonna be cos theta. Mu mg cos theta f is equal to ma. We cancel you can find sine and cosine using this. Okay. Okay. I kinda get what I should be doing for the first one. Compute the time travel taken down to root A. So we got the acceleration. Initial velocity is gonna be zero, right? No initial velocity, so v square minus u square. But that is even there, we only get the final velocity. What did you do to s is equal to half a1 t1 square? Accelerated motion on an inclined surface. Yeah, okay, it's just okay, it's s is equal to ut plus half at square. Okay. Calculate the net acceleration for each segment. History set a timer for 15 minutes. Net acceleration for each segment in route B. Okay. Determine the time travel for each segment and total time for route B. Determine the time travel for each segment and total time for route B. Okay. Compare the total times for route A and B to determine which route is faster under a given condition. So, calculate the net acceleration for each segment in route B. So here the angle is going to change. Is it better to find the angle itself? Yep, they did find the angle. So A1, no, A2 what? Okay, A22 equals nu G. Why though? Minus nu G, that's pretty, it's either you have to find the final velocity from here. Determine that after it reaches the plane, it still has 4. So that's why they are asking for 2. So I just saw the equation for the equation for the I didn't get that. I thought we had to calculate the A2 from when it down and then the deceleration due to friction and how much until stopped. But could you explain why the given solution works? What? Gravity mg always points straight down regardless of the plane. when we resolve mg to these components parallel to the plane, perpendicular to the plane. This is not usual horizontal vertical split. It's a tilted axis, which is why sine and cosine is swapped compared to the flat ground. Key rule to remember: the component along the slope is always mg sine theta. Why friction as cos theta? Okay. Net acceleration on inclined plane A. Dude, inclined plane B, bro. A2 equals minus nu g. I know it's deceleration, but it's minus nu g. That's it. No m nothing. I guess. Now what's the last part? Determine the time travel for each segment and the total time for route B. Route B. Route. T21 equals 2 times. Is it from this? Yup. We got initial velocity 0, so 1.52. Velocity at the end of the inclined plane A equals A into T2. Okay. V equals AT. V equals AT. I need to remember that. Motion on the straight segment AB with the length. Which of these solutions is realistic? Why do we got two? Okay, we. Uh, Maximum value the body needs on the straight line. Whoa, what is the equation you used? 0 equals v2 minus nu t. So t2 max v2 by nu g. What is this equation? v2 minus nu g t2. Maximum t2. The body needs on the straight segment is v final equals 0. Okay. So is it v1 minus v2 type sheet? v2 by nu g. Nu GT2 max. Nu G, is that V minus U is equal to AT? AT, not ST. ATV equals U plus AT. Okay. 2.T2 equals T 1.52 plus okay. Route B is faster. Okay. Even if there was more friction, then maybe route A would have been faster. So that's the only question on this page. Let me try doing this. Ça, dis-moi. Qu'est-ce que tu veux? Ça, dis-moi. If I start doing this, come on. Come on, boy. The body is required to move from point A, starting from rest, point B. Determine the net acceleration A of the body on route A. Okay, net acceleration. Let's start. It's gonna be G. We got normal. This is FR friction. FN, kinda. This would be theta. So 4F equals F equals I know it's mg sine theta minus fr 15 minutes, come on. Let's reset a timer for 10 minutes. FR equals new and mg cos theta. How do we find theta? Then theta equals 3 by 8. Theta equals tan inverse. What is 3 by 8? 0.375. We got 20.5. So we get the, what can we take out as common? G sine theta minus nu cos theta. F equals a. Is it acceleration of vector? I don't exactly know. G sine 20.5 minus 0.2 cos 20.5. Zero 0.164. 9.81. What was it? 9.81. 1.6 meter per second square. That's what it is saying. I believe so. Compute the time taken for the body to travel down route A. Oh, come on. 64 plus 9. 8.54. 0.54 meters. So S equals ut plus half at square. Do we have time? We have to find the time. Okay. Root of 17 by 10.6 root 3.26 seconds. Okay. Net the acceleration for each segment in route B. Each segment, so A, A dash, B. So in total, route B has to travel more distance. Okay. So how do I find this? First, I need to figure out the acceleration. Sign data. No, 10. $36.86. 36.86. So just like that, A2. F by M. 0.6. 2.2. 0.44 into 9 point. Meter per second square for first half. Okay. How much do we got on? It's 1.6. What? Whatever you say, bro. Wait. V minus U equals AT, right? But we don't know AT though. 10 minutes. God damn it. We should set a timer for 5 minutes. Come on, come on, come on. Come on, come on, come on. S is equal to UT. Is that the formula? Yeah. S equals. No. Uh, T equals root of 2S by A. T dash 10 by 2.3 root of 2.3. That's gonna be different. 1.52. I think that 1.52 is for, yeah, that's for part D, but it's okay. We have to find the acceleration at each segment. One point five two 6.536. So that's V at A dash. Okay. Minus 6.5 into 6. 42.25. 2S. What is 2S? What is got S? 4. 8. Minus 5.28 meter per second square. That's the deceleration. I guess. I'm not sure. So if that's the deceleration, then V minus U equals AT again. T double dash equals 0 minus 6.5 divided by 5.28. 1.23. 1 point plus 1.5 to 2.78. 78 seconds. What's the other one? 3 point. Okay. No way. I actually used a different method to find the answer. That's good. That means I can do something when it's exam time. Stupid. I apologize, people. Nothing was seen, right? Okay. So this time I used a different method to get the answer, and from the looks of it, route B is faster. Okay, that's done. That's done. You get the fuck out of the way, boy. Now the next one. 5 minutes? Okay, okay, come on, come on, come on. Hey Siri, set a timer for 15 minutes. I haven't done the 12, assignment 12. Oh, sir. Stop doing this, boy. Oh, where is it? Stop listening to music. I got no money. Oh, that's pretty long. Gotta do it though. Come on. Talk to me, girl. Discuss the effects of losing a supporting component in the balance system. How might this impact the forces acting on the system and its subsequent motion? The subsequent motion would be in the opposite direction, where opposite direction uh, of the supporting component. How might this impact the forces acting on the system? It increases tension, I believe. Increase tension on the other systems. I don't. Increase tension on the other supporting equally. That's what I think it is. I'm stupid, bro. When a supporting component is lost, the previously balanced equilibrium system, the system is no longer in equilibrium. This has the direct consequence of the forces in motion. The supporting component usually provides a force that counteracts gravity or applied forces. When the supporting is removed, the force vanishes instantly. The remaining force no longer cancels, so normal force decreases or becomes zero. Tension force disappears. Weight is no longer balanced. Consequence for the motion. System designed with reductant supports may redistribute forces, remain stable. System without redundancy may experience sudden acceleration, structure failure, collapse statement. Okay. How can the weight measured by a scale in an elevator be used to determine if the elevator is moving up or down? What? How can the weight measured by a scale in an elevator be used to determine if the elevator is moving up or down? If I understand this correctly, when elevator is going up, the weight is gonna show higher mass or higher readings. If it's going down, lower weight. How does the friction affect the motion of an object? Define static friction and kinetic friction. Okay. Okay. The key idea is the scale measures the normal force, not the true weight. Changes in this measured force tells you the elevator motion, what the scale actually means. True weight, scale reading, normal force exerted by the scale on you. Elevator is acceleration upwards. Scale weighs more than mg. Yeah, I was right. You goddamn right. When they say of physics, they think of me. I'm the danger. How does friction affect the motion of an object? Define static friction and kinetic friction. I don't know. How does friction affect the motion of an object? Define static friction and kinetic friction. Static friction. Static friction is when the object is at rest. Is that what it is? Is that what it is? Effects of friction on a motion. Friction is a force that opposes relative motion between two surfaces in contact. Its effects are reduces or prevents motion, causes deceleration, converts mechanical energy into heat, enable motion by providing grip. Come on! Don't waste time, boy. Friction is a force that opposes relative motion between two surfaces in contact. Its effects are reduces or prevents motion, causes deceleration, converts mechanical energy to heat, can enable motion. Static friction. Static friction acts when two surfaces are in contact but not sliding relative to each other. Yeah, when it's at the rest. Example, pushing a box does not move. Maximum value. Uh-huh. Kinetic friction. Kinetic friction acts when surfaces are sliding relative to each other. Approximate constant in magnitude given by opposes the direction of motion smaller the maximum static friction. Example is box sliding across the floor. What? No way, I did not accept that. occurs no sliding, variable force, constant force, larger maximum, slower magnitude, prevents motion, slows motion. Okay. Now, to estimate the height of a 13-story TNF tower, stand on a scale while riding the elevator. Estimate the higher height of TNF tower using the following data. Before starting, the scale displays F of A is equal to 490 Newton. During startup, the scale shows the force 550 Newton for a period of time, 3 seconds. Subsequently, the balance displays the force 490 Newton for a period of time. Subsequently, not gonna lie, I'm pretty confused on the meaning of the word subsequently. Mhm. Finally, the balance shows force 430 Newton at 3 seconds, then the elevator stops. Were you going up or down? First, first was going up, down. Cheesecake, cheesecake. Resting state. F of A equals mg, 49 kilograms, 10 meter per second. Okay. T1. F of B greater than F of A. Additional force exhibited on the scale. Person experiences an additional force down upwards. The elevator moves upwards during the T1. Mhm. I believe it's due to inertia, right? Initial reading during start, constant speed, slowing down. M can be estimated from initial reading, direction of motion. Use the scale rating compared to normal weight. A is greater than 0, elevator was accelerating upwards. It should be FFC, right? Or am I missing something? Oh, how did you calculate the height? What acceleration did you experience while driving? Change in force by mass? Mm-hmm. Change in force by mass. What is that exactly? FFP equals mg plus ma. Is equal to fa plus ma. Newton's third law. Okay, not gonna lie, this part was pretty good. I did not, my mind did not come up with the part where if the elevator is moving at a constant speed, then the force acting on the body returns to normal gravity type she. Okay. hmm Using the scale reading compared to normal weight, g plus a. We have to find a. Okay. Okay. Normal force equals m into g plus a. If it was going down, I think it's gonna be g minus a. So from this, okay, just half at square. Okay, v1 equals a delta t. Velocity is 3.66 meter per second. What acceleration did you experience while driving up? At what maximum speed does the elevator move? At what height is the 13th floor of the tower? Wait, we already found the height, right? Or what is this height? That's just for T1. Okay. Mm-hmm. V delta T2. Then there's a deceleration coming up, right? F of D less than F of A equals F of C. Reduced force exhibited on the scale the person experienced. So F of D equals minus. Yep. Mm-hmm. Mm-hmm. So it's gonna be a total of okay. Oh, there are three questions. A van with mass M1 tows a car of mass M2 with a tow rope of mass The tow rope is not stretchable and always tensioned. The rolling friction of the vehicle is described as the friction force for the van equals 300 Newton for the car. I'm guessing that's the frictional force acting against the vehicle. I'm getting distracted. Okay. Create a free body diagram for the van, the car, and the rope by drawing boundaries around the bodies and the forces acting on each of them. And rear and front friction based by the car, the force downwards. That's the rope tension. Okay. Yeah, we got the rope tension here. And front normal forces on the wheels, normal force on the wheels. Where's end front, bro? There it is. F thrust. Where's F thrust? M2G. M2 is greater than M1 and M3. I'm guessing these are M1 and M3. No, M2 is very low than M1. Oh, it was the car and truck. Write the Newton equation of motion for the three bodies. Newton equation? Like a Newton's equation? How do I write it though? Rope always tensioned. A1 equals A2 equals A3 equals A. M1A F thrust minus F1 minus S1. M2A S1 minus S2. M3A equals S2 minus F car. Wait, what? Something ain't right. Something ain't right. Just gonna take a 5 minute silence, okay? I should reset a timer for 5 minutes. 5 minutes. No, why did I remember that? ARL from somewhere. Hey yo, what's up, gang? I got an exam coming up, and I'm pretty scared. How's it going? Which exam? Physics exam. Uh, it's at 12. I got 2 hours. God damn it. Am I scared? Yes, I am scared like a baby. But would I fail? It's all in the hands of everything. Not me. Not me though. Come on, bro. Please. I just wish they ask me questions that has something to do with, I don't know, S equals UT plus half AT square. What's the name of that equation? 18 seconds. Okay, that's 5 minutes. What is? No, I mean like is it competitive exam or just midterms? Yeah, it's like a first semester exam. It's not a competitive exam. It's just a basic physics exam. Not nothing big. Uh, this second equation of motion. Okay. Oh, yep. I mean, the exam. At least the topics for the exam is not that hard. It's just normal, basic physics that you learn in school. But if you are someone who is pretty stupid and your memory is not that good, it's gonna be hard. Okay, let me try this. Let me give on a straight flat village road. Okay, with a maximum speed of 50, two cars drive at a distance of blah blah blah. First car which drives with the allowed maximum speed is forced at t equals 0 by a playing child to a full braking, so that the car only slips. Where does the car stop if the coefficient of static friction is zero point 0.5? The second driver driving with speed 70 kilometer per hour reacts after zero point 0.2 seconds, also with an emergency braking. Check whether two cars collide. Check whether two cars collide. Let's go step by step. Step by step. Rope is massless or very small. Inextensible tension always acts. Feel free. Free body diagram. I kind of know the free body diagram. It's just the Newton equation. Assume forward equals positive F traction minus F plan minus TF. Did they account for F traction though? It's F thrust. Okay. How does the van move? The friction force is essential for the van to move forward. The van's engine transfers its power to the wheels, who push backwards against the street surface. According to Newton's third law, the road exerts an equal and opposite force forward on the wheels. This driving force is the thrust that propels the car. If the tires lose grip, the static friction decreases, and the wheels may spin without generating effective thrust, causing the car to slip. Hmm. car, T R minus F car equals M3A. Rope if massive, small, M2 0, then TF equals TR equals T. Am I stupid, or why don't I understand what I'm reading? F traction minus Fn minus T equals 0. F traction equals T equals F of car equals 150 Newton. Again, from what I understood, F of car, that's the frictional force, right? Right? Plus 150 van road force, 450 Newton. Let me see the next question, okay? I'm just curious. What's the next question? If it's taking too much brain tokens, I think I should skip it. Explain the concept of equilibrium. How does an object achieve equilibrium in the terms of forces acting upon it? How does an object achieve equilibrium? An object achieve equilibrium when the opposing forces equalize. Right? Yeah. How does forces affect the motion of an object according to Newton's first law? Dude, what's Newton's first law? I don't remember. How do you determine the resultant force when multiple forces are acting on an object? How do you determine the resultant forces when multiple forces are acting on the object? You find the common vector of the multiple forces acting on the object, and the resultant force would be in the direction with the most number of uh, vectors. Common vectors, that's what I think. Which forces act on the two arms of the man in the picture? Which forces act on the. Okay, one is a tree, it's a stop. A horse can move. Oh, no, no, I don't think it's no force. Is it though? Newton's first law is that object in motion will stay in motion. Okay, unless the force is applied on it. Okay. How do forces affect the motion of an object according to Newton's law, first law? So, according to first law, the motion of an object is not affected until an external force is applied. How do forces affect the motion? Forces result in change in direction, change in motion depending on the. Okay, I need to formulate correct sentences for that, but I think it's just that. I think the question is asking how can force affect, and I think it depends on the direction where the external force is applied. Okay. No net force, no change in motion. Force causes change in motion. Direction of the force matters. Yep, direction matters. That object will move in the direction of that force. Okay, if it's a object in rest. Newton's first law show that motion does not require a continuous force, only a force to change the current state. Okay. Between two buildings, mm, a 13-meter long mastless cable is suspended at building A. The height of the suspension point is 5 meters above the ground. At building B, only 4 meters. A lamp is suspended under the following conditions. The lamp is mounted, fixed on the rope. The length of the cable from house A to the lamp should be 8 meters. Calculate the height of the lamp above the street and horizontal distance to the houses. What force is acting on the hook at the suspension point of the two buildings? Mm-hmm. Why do we have two angles? Oh, it's the okay. Okay, it's 9 a.m., 9 to 10, 1 hour, 10 to 11, 1 hour, 2 hours. How can I make use of these 2 hours? I could look into the equations, yeah. Free body diagram, yeah. Sine omega, what is this? Forgot the name. It's not lambda. Lambda is opposite. A1 by 8, 6.54 by 8, 54.83 degrees. Sine delta equals B1 by 5. Where's delta though? Okay, that's the delta, okay. Mm-hmm. Mm-hmm. I should do this one. Rope always get tensed. A equals A1. A2. What is this A? Which A is this? This driving force is a thrust that propels the car. If the tires lose grip, the static friction decreases. The wheels may spin without generating effective thrust, causing the car to slip. Okay, okay. M1A equals F thrust minus F1. M2A equals S1 minus S2. Okay, okay. M3A is S2 minus the car. Okay. F thrust minus F of van minus S1. Okay. So the van has to deal with S1, F of van. Uh-huh. Constant velocity, uniform motion. A1 equals A2 equals A3 equals 0. So acceleration is 0. S1 equals S2 equals S. Okay. S2 equals F of car. 50 Newton. F of thrust equals F van plus S1. So F of van plus F of car. F of thrust for 50 Newton. So okay. Calculate the rope tension at the rear end of the rope if the van accelerates. So rear end would be S2, right? S2 equals M3A minus or plus F of car. 1000 times A. Okay, okay. I should know these, okay. F of thrust when calculate the force exerted by the street on the tires of the van during accelerated motion. So we should find F of van, right? Or F of thrust. Which books do you use for physics? Guess what? No books. I don't use books. I need to get into books. But right now, no. But I think I do have some books saved, but I never read them. Let me see. Oh. Yeah, that's pretty disappointing, not gonna lie. If you're a student, you should have some books. So, I got 3 books. One is organic chemistry, the other one is art of electronics. So, no books related to uh what type of physics is this? Kinetics? Yep. Do you have any physics? Do you refer any physics books? On a straight flat village road with maximum speed of 2 cars drive at a distance of 20 meters at time t equals 0. The first car, which drives at the allowed maximum speed, is forced at t equals 0 by playing for full braking so that the car only slips. If I remember, collision. Where does the car stop if the coefficient of static friction is 0.5? The second driver, driving with the speed of 70 kilometer per hour, reacts after t equals 0.2 seconds with an emergency braking, checking whether 2 cars collide. G equals 9.81. So, where does the car stop if the coefficient of static friction is zero point 0.5? We're talking about the first car, it was driving at 50 kilometers per hour. The distance is 20 meters, right? Non-uniform decelerated motion. When car stops, is 0 equals 0, v1 equals 0. I study from Principles of Physics by Halliday, Resnick, and Walker, and Calculus Early Transcendentials by James Stewart. Okay, let me check these books. I appreciate you for dropping book knowledge. Mm-hmm. It's available in the archive. Can I get it though? Nope. Okay. Oh, it is available. Okay. Use your free account to borrow this. Okay. Interactive focus on conceptual understanding. 12th. Okay, 12th. Mm-hmm. What was the other one? Calculus. Uh-huh. History of mathematics. Okay. Have you completed reading this or are you still in the process? Oh Lord. Okay, start solving this one first. Still in the process. Okay. Hey, that's good. Reading a book. I mean, when I was in school, maybe I read books, but that was some CBSE Indian syllabus type of books. Dude, I forgot the name of the book. Indian syllabus is trash, to be honest. I don't know. It was pretty okay. I remember in 12th, they taught me vectors. I did also take they crammed 80% of the physics in class 11th and 12th. Okay. Yep. I kind of agree on that. They should have at least started, slowly ramping up. How is a student supposed to do university level stuff in 2 years of school? I kind of agree on that. Yep. They did teach a lot of, you know, basic stuff that is needed for university, but they should have started from early. Yep. I know exactly what you're saying. Like, they kind of rushed it. Feels like they're trying to screen students. Fast? No, fast. Quickly, not fast, fat. Okay, let me try doing this. I'm gonna share the screen. I might not see the chat for a bit. Ninth and 10th grade physics was so basic, like seventh grader could do the math in there. They at least could have included vectors or sets in class 10 math. Yep. They could have at least start with the concepts. Like, bro, there is something like this, okay? They could have started implementing. But hey, 3 seconds, okay. Come on, come on. F of P equals 550 Newton. Oh shit, I forgot. Oh shit, I forgot how to start this. Were you going up or down? We were going up. D. Wait. You're going up, right? We're going up. I just forgot how to calculate the rest. You first calculate the mass, okay? Acceleration at the start. Uh, from the mass, you calculate the. Okay. Minus 10. Whoa. Because the force is positive. Are you this one? I mean, we start from 490 and we're at 550, so you're going up. I'm guessing that's the one you're talking, right? I'm pretty confused on the minus C. What? F equals M into G plus A. Okay. G plus A. No, like, because the force is positive, so you would be going up. Positive, like, are you talking about FB when you subtract FB with FA? It's gonna give you a positive value. If it was a negative value, then it means the elevator was going down, or at least it means it's going down. I don't know exactly how to say it. So, okay, I'm gonna share again. G plus A. So, for no 550 equals 49. $60, right? Yep. 60 divided by 1.2. Meter per second square. Now T f of A equals 490. F of C equals 490. Okay, that was okay. What acceleration did you experience when driving? What acceleration did you experience while driving? What maximum speed does the elevator move? Okay, so we have to find. So we got the acceleration. S is equal to. No, not S. No. S is equal to U half AT squared. That's not gonna work. Cause oh yeah. 5.4 meters. Okay. So what's the velocity? Oh, V equals to AT. 3.6 meter per second. S is equal to UT. $46.8 meters. Okay. $50 equals 430 Newton. So 60 minus 60 Newton. G minus A. So is it minus 11.2 meter per second square? That's what? Something ain't right. Something ain't right. It's either this part. I think it should be 430 Newton equals mfg minus a, and a equals 430 divided by 49. Divide. Boom. Minus 1.2. Yep. Yep. What? Oh, we got an initial velocity, right? Yep, 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 yep. Oh, fuck. I forgot. It was 5.4. Oh, that's the same thing. Okay. Okay. Head of the building, I believe. If you imagine that in the situation, I think it makes sense because the difference is positive. Yeah, difference is positive. That was okay. That was kind of okay. What was 12th question? Let me just cross check real fast. Bus vectors. Collision. I should do this. But before I do this, I think I should need one more cup of coffee. Oh, is this the last moment hangover? How do I reply to this? I just need a one line. Okay. 50 minutes to your exam. Yeah, yeah, yeah. Whoa, I'm getting distracted. I'm gonna go get a cup of coffee and be right back. Just 5 minutes or something. Oh, right now. Good luck. I gotta go. ARL from somewhere. I really appreciate you for checking out the stream, man. Oh, whoa. Focus. Particle of mass m1, constant velocity at the time t, collides perfectly inelastically at the origin. Whose constant velocity before collision? Uh-huh. What was the distance between two particles before 1 second before the collision? I kind of remember this, but you take the vector, you multiply it by mass to get the that's velocity, right? You need a position of a particle, r0 at t equals 0, collision at the origin. 1 second before collision, t equals -1, r -1. So you just, okay, convert the velocity vector to, okay, distance between them. What is the distance between, okay, so where does mass come in? When the kinetic energy of the particles before the collision, what are the kinetic energy of the particle before collision? Half mv square, half v square is equal to v square equals, but okay, yeah, it's a square of magnitude. Okay, 36 joules. What is the velocity of the vector? Velocity of the combined particle after collision. Velocity of the combined particle after collision, m1 vf. Okay, the combined particle velocity vf is going to be, so it's going to be momentum conservation. That's what it is. Okay. Mm-hmm. Mhm. Yep. One more hour. I'm guessing that river crossing question is gonna come. The boat crossing the river. That was example 7. Yep. And I wish the first, like, about the graphs. I wish they asked me about the graphs because I know a little bit about the graphs. What? Be right back. Back, 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 back. Okay, 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 okay. I was doing this one, right? What is the fraction of kinetic energy which is converted into internal energy? That's gonna be after the collision. Hmm. Okay. Yeah. I don't think I don't think elastic collision is gonna be asked, cause you know, you know. Okay, I'm gonna share the screen. Might not be visible. Everything might not be weeby boo. So, what is the distance between two particles 1 second before the collision? T equals 0, collision. Therefore, T equals -1, 1 second before collision. V1 -3I plus 2J minus 1K. No, -3I minus 2J plus 1K. vector magnitude equals 13, 14, root 14 2 minus 2 minus 4. 20, 24, root 24. .7 4.9. No, this is not how you calculate, boy. So you subtract these two, right? So now there R1, R2, R1 minus R2 minus 1i plus 0j plus 5k. Resultant equals root of 1 plus 25. Root 26. 5.09. Is that the distance between them? I believe that's somewhat the answer. 7. Okay, what did I make a mistake? What was the mistake I made? R of minus 1. R1 minus R2. Three minus 2 is minus 5. Okay. Okay. I got my mistake. I understand my mistake. I did a bit fast, man. Okay. What were the kinetic energies of the two particles after collision? Okay. Inelastic collision, conservation of momentum. M1 plus M2 VF equals M1 V1 plus M2 V2. VF equals 1 by M1. Okay. So 2 and 3. Can I look at the screen and write? Let me try that. 1 by 5. 2. I can kind of do it. If, oh, is that option available? To see my, no, I don't think I could not see the tip. That came out wrong. 3, 2 minus 1. 3 by 5 minus 2. Four. 4. 6 by 5 plus minus 6 by 5. Oh, that's literally canceling out. 4 by 5 plus 6, 6 by 5, 10 by 5. 0i plus 2j minus 2 by 5 plus 12 by 5 plus 2k cap. Whoa. Is that the answer though? I don't know. That is the velocity. What fraction of the kinetic energy was converted into internal energy? This is the velocity vector. If you're talking speed, it's gonna be like 4 plus 4 root 8. .8. 2.83 meter per second. What fraction of the kinetic energy was converted into internal energy? Kinetic energy equals half mv square. So Ke initial equals Ke final, half m1v1 plus half m2v2 equals half m1 plus m2 vf. So how much was lost? Let me see that. Do we use the vector? Yo, 10 minutes left. More like 45-ish. But yep. One part of my brain is telling me it's gonna be alright. The other part is like, bro, if you fail, you gotta do this again. So, kinetic energy before collision. Okay, you use dv like v. Okay, okay, okay. And you took the difference? No, you add them up. Velocity of the combined particle. Vf is equal to, yeah, that's the one. 0, 10, 10. No, I got 0, 2, 2. Yeah, 0, 2, 2. Okay. Velocity after collision, that's right. Fraction of kinetic energy converted to internal energy. So you add the initial kinetic energies. Okay, m1 half mv square, right? Okay, I missed the v square. ARL from somewhere, you're back. It's crazy. What is this message? I don't know if you already answered, but would be possible. Theoretically, that she can state in the take some course. They're trying to push a master's student to bachelor's. That's interesting. Okay. Half m1 m2 vf. So you take the sum of the initial kinetic energies, and just like that you also take the final kinetic energy. You take the difference. That is the energy lost, or internal energy, 30 joules, and that internal energy divided by initial uh, total kinetic energy is what's converted to internal energy, the percentage of which that is converted to internal energy. Internal energy, let me do that. Square, right? So root 14, 24. I think those two are correct, right? So half into 2 plus half into 3 times 24. 14 plus 36. 50 joules. Okay. Now 8, 4, 20 joules. Delta KE 60%. Am I proud of that? No. I had to look for answers two times, not one. Pum, 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 pum. A bullet of mass. So this one was related to. Before collision, bullet moves with velocity v. Bullet, one-dimensional problem after collision. So half mv squared is equal to half d. Okay, that was the one I did not know. Half dx max. X max is the distance traveled by the wooden block, and d was the spring constant. What the focus, brother? What is this? Okay, this is the question I should be remembering. During the short collision, external impulse from the spring is negligible, so momentum is conserved for the bullet plus block. So mass of the bullet times velocity of the bullet equals mass of the block plus mass of the bullet times initial velocity of the bullet, initial velocity of the whole block. Mm-hmm. I'm gonna share again. Momentum is conserved. Again here. Momentum is conserved. Think. Momentum is conserved. So mm-hmm. 10 raised to minus 2. Newton per meter. Okay. A maximum elongation x max equals 10 divided by 100 meter. So half m plus m v equals half d x max drk x max square. What by 100. So we got 4 divided by 0.01. I don't think that makes a big difference, but let's stick through 3.96 meter per second. Okay. From this, we could calculate the after collision says at what speed does the bullet hit the wooden block? bullet just before collision. Conservation, momentum, therefore mvb equals half wait 1.01 3.96 399 approximately 400 meter per second. Are the units correct though? Meter, Newton per meter, kilogram. Yeah, I believe meter units are correct. $200. That's the problem. I got 3.96. Why? It was V square. Yeah. Yep. What is this one then? During the short collision, momentum is conserved. mv equals. Inelastic collision, kinetic energy is not conserved. Some of this is converted to internal energy. However, momentum is conserved. I wrote that, but I took the kinetic. Okay, kinetic energy, elastic collision. In inelastic collision, kinetic energy is not conserved. Okay. Eighth solution. 8, 7, 6, 5, 4. Oh Lord. 3. Those are same. Now let's do with the river speed. What's the speed of the river? River. Recap kinetics. Calculating with units. In the lecture, the formula horizontal range of a projectile is. Goddamn. Two-dimensional vector superposition. Imagine you want to cross the Danube at Linz using motorboat. At this point, the Danube flows east to east. West east, right? West east. Okay, okay. It flows like this. Oh, flows like this. Okay, stop. Your destination lies to the north, directly across the opposite side of the river. At what angle to the north-south direction? What angle to the north-south? Okay. Mhm. If it's flowing in the west, I think you should go. If it's flowing towards the east, I think we should go south. No, west, and it's gonna be a hyperbolic. At what angle? What is the resulting speed, magnitude, and direction of your boat if you steer it exactly north? What is the resulting speed? The noob has a width of 250 meters in Linz area. How long will it take you to cross in both cases? How far will you be swept downstream in the second case? 1 knot is One SM is a nautical mile, 1,852. River speed, boat speed, speed of 6 knots. Okay. Nine, nine. Okay, so first part is conversion. Steer angle to go straight. The T to be the angle west. The okay to cancel reverse drive. VF boat. X plus river equals 0. What do you mean? Come on. VF boat sine theta. So this component would be sine. This component, the vertical component, would be cos. Based on the angle, this is cos. This is sine. Okay. Sine theta is opposite by velocity of boat. It's kind of starting to make sense to me, but sine theta, that's the theta. Theta is sine is opposite by hypotenuse, right? The hypotenuse is the velocity of boat. Hypotenuse is at the bottom, opposite is kinda the flow of the river. Okay, 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 okay. I get it, boy. Oh, we got it. Would I be hungry during the exam time? I could be. I should get something to eat. Yo, Mikhailish. Not gonna lie, your name is kind of hard to pronounce, but I did get the first part right. Mikhailish. Dude, it's me. I know you can do it. Do it. Yes. It is always. I mean, if I do it, that's good. If I don't, I do it again. That's it. That's it. End the story. That's shit how it should be. But it should be good. It's 6 questions, three questions, theory, three theory questions, and three uh, yeah, calculation questions. Should be doable, bro. But hey, I appreciate you for checking out the stream. So I got the angle. What angle? Okay, I got the angle. What is the resulting speed of the boat if you steer it exactly north? Exactly north. Oh, we got the time too, okay? 64 degree. So the northward component of the velocity equals velocity of boat times cos theta. Ah, 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 ah. Okay, okay. But why do you need the north component? Am I missing something? How you doing, bro? Mikhailash, how you doing? 3.1 minutes. Why though? Why would you find the north component? Like, what is the use? Northward component of the velocity. Time to cross. Oh, you calculate it as a straight line with the north. Mm. Mm-mm-mm. So what is the use of this horizontal vector that is used to find the angle? Okay, okay. Should I do it? I feel like I have time to do this question, yes? Resulting velocity components. Vfx equals v river. What? How is it vf river? How though? Meter per hour. Why would you even use the knot? I mean, I would rather prefer knots, conversion of knot, than some integration, right? So I appreciate that. Resultant speed. V resultant equals Vx square plus Vy square. Again, Vx is the east direction x here now? How is that x? Am I stupid? Yeah, I am stupid. But hey, stupid people gotta live. Stupid people. Stupid people gotta learn. Not everyone is. Okay, stop, bro, stop. Okay. Mm-hmm. Mm-hmm. I don't get the what direction and angle of the east. So that's gonna be what is this? Omega? No, that's beta. That's not beta. That's theta, I guess. Arc tan or tan inverse, right? How much did you get, bro? 64. Okay, that's pretty correct. Ah, what? That's how much the boat is gonna deviate from the normal. Yep, that's how much it's gonna deviate. Oh, I should check where is the exam held. H is 10. Where's H is 10? It's underground somewhere. No, it's. Oh, yeah, H is 10, of course. I know H is 10. Bish, a page. I still didn't get this one. The magnitude of the velocity is determined by using the right angle vector triangle. Okay. Okay. V total is equal to 14 point. That's velocity is determined using right angle velocity triangle. What? What? VD? Yeah. Okay. VD is the velocity of the river. Yeah. VD is the velocity of river, but why is it on the top? Wait, tan is what is tan? Opposite by opposite by Okay. So tan theta is VD. Okay, now I get the VD. VD by speed of the boat. Mm-hmm. So we got the angle, but V total. Now, not gonna lie, these some of these songs are just straight up trash. I get it. We're going straight, so due to the current, we're gonna go right. So we're gonna be affected. Our uh, horizontal vector component is gonna be affected by the flow of river, river. The time to cross the river is calculated using the width of the Danube. Velocity in the north direction. We got two cars. Choose the location of car A. How far car A traveled when it's overtaken by car B. So car B has more speed, and car B is traveling at a constant speed of 110 kilometers per hour. Okay, that's a pretty good question. At time t equals 0, it's set to minus 4.5 xt. What are these videos, bro? At the moment, T1, oddly suspicious, having trouble. I wouldn't say trouble. I got my exam in about. I should be leaving at 11:30, so 20 minutes. 20 minutes, and it's gonna be physics exam. It can be whatever. It can be the easiest question I ever seen, or some shit that I never seen before. So, oddly suspicious. I appreciate you for checking out the stream though. So, where was I? I was looking at this question. How far has car A traveled when it's overtaken by car B? Car B overtakes car XAT1 equals XBT1. I'm guessing at that time they both uh, are same distance from the origin. VAT1 equals X0B plus VB plus T1. What is X0 though? What is T1 though? T T1 equals X0B by VA minus VB minus 4.5. That's the initial position of car B from origin, okay? I just know that before the exam I should look into some equations. Oh. So within 540 seconds, the car B should overtake. Velocity of car A with T1 equals the separation of car B with A plus V T1. And we gotta find T1. We know X0 is 4.5. Okay. Okay. Kinda get it. I kinda get it. But I don't know if I could do this part when I'm in exam. So after calculating T1, XAT1 equals VAT1. XA, I believe it's the distance traveled by car 1, 12 kilometers. So after 12 kilometers, they're gonna be at same position. 12 kilometers, that's a long. Considering one is 80 and the other is 110. Okay. Is there any relation from these two? 110, 80, or 30? 30 and 12. How are they related? They're both multiples of 3. If I divide them, it's going to be 15 by 6. 15 by 6. 5 by 2. 5 by 2. 5 by 2. No, I'm not going to think too much because it's going to be wasting my time. 30 seconds after. How far ahead is car B from car A within 30 seconds after overtaking? T is equal to 30 seconds. 30 seconds after overtaking, it's going to be. Okay. And okay. I mean, if you calculate the. You could just multiply, right? 30 seconds. meter per second. It should be meter per second or it's kilometer per hour. It's either we have to convert it. 110 to 5. 30 second divided by 2. Yep. 15.27. What did I calculate? According to my calculation, it should be 15.27 meters. I mean, car A is also traveling forward. Okay. I did not account for that. Oh, that's where they meet, huh? 12, okay. I think I should try doing this. I have time, I have 15 minutes. 15 minutes is enough. Nautical mile is I'm gonna share the screen. Let me see if I could solve it. What? What happened to the pencil though? Did it just give up? Just give up, bro? Just a minute. Okay, that's working. There we go. See how we go. Change the pencil color Why? Why though? That's a new account. Also, I gotta say, when I share my screen, I won't be able to see the chat, okay? Not like it matters, but your destination lies to north. So as we go, there we go. The river. The river has a flow of 10 kilometers per hour. We got our boat. Oh man, gotta draw a boat. That's boat. That's boat enough. So that's the first case, theta. That's the second case, beta, beta. It's about 250 meters, right? Yeah. I should convert first, right? So 6 knots. 6 SM/hour. 6 into 1/8. 1852 per hour. Oh, that's too much, too fast. What? Did I miss something? Did I miss something though? Edits. Just editing cricket videos. Oh yeah, bro. 2 years ago. Okay. 6 not 6. Why did you divide it by? That's for meter per second. Okay. Okay. Condition: no horizontal drift. No horizontal drift. Sinus. Okay. You know what, gang? I'm gonna end the stream. Let's just hope it goes well. Peace out, YouTube. I mean, I'm gonna end with I'm gonna look through all the formulas, important ones, and yo, I appreciate everyone for checking out the stream. It means a lot. It means a lot. Peace out, YouTube.